and Earth 2.0. This artist rendering shows the rocky planet identified as Proxima B.
Astronomers have hit the jackpot. This is a dream come true.
Something terrifying just came through. Quantum AI decoded James Webb's data on Proxima B, and what it found is a nightmare. Scientists finally got the answers regular computers missed, and the patterns in methane and heat show signs that the planet might actually be alive. Let us zoom in closer to what the quantum AI spotted, because those hotspots might not just be water or volcanoes. They might be something watching us back. The planet next door just blinked. Proxima B has always been the golden child of nearby planets. It is close, relatively speaking. Just over 4 light-years away, orbiting the star next door. Scientists have been focused on its potential for life, but all that attention ran into a wall. The James Webb telescope dumped a mountain of data, and regular machines could not make sense of it. It was like trying to hear a whisper during a thunderstorm. Now the whisper has become clearer. What it says changes everything we thought we knew about habitable worlds. Here is what changed. The quantum machine did not just process the signal better. It picked out patterns in the air around Proxima B. Strange ones. Something about the methane there. It goes up and down in a way that is not random. That kind of swing usually means there is a repeating process. On Earth, a change like that often connects to life. The computers just show the data, and the data is strange. These patterns were not just barely visible. They were deep under what looked like static, noise. The new machine cleared out the mess and showed the signals cleanly. Before this, anyone looking at that same data only saw a confusing mess. After the quantum system stepped in, a pulse came out, a rhythm, the kind you expect from a planet that is alive in some way. Then came the look at carbon dioxide. The machine spotted short seasons. Not like the 4 we have here. This planet moves fast. A whole year on Proxima B is just over 11 Earth days. During that time, carbon dioxide levels rise and fall in a clear cycle. That regular rise and fall points to a planet that is not just sitting there frozen. It moves. It breathes in its own way. Proxima B is locked in place with its star. One side always faces the light. One side always sits in the dark. That kind of setup should mean one side is burning hot and the other is freezing cold. But this new look shows that the air might be flowing around the planet. Heat might be spreading out more evenly. That means the planet might not be as extreme as everyone thought. There might be more places where conditions are not terrible. Then came the next piece of data, heat maps. The telescope picked up heat patterns on the surface. Nothing clear at first, just smooth shifts from hot to cold. But once the quantum machine stepped in, new shapes appeared. Hotspots, small areas that were clearly warmer than the rest. These hotspots sit along the place where day turns to night, that thin edge where light fades into shadow. But the quantum system wasn't done yet. It still had one more hidden pattern to reveal, the warm edge of a cold planet. In those regions, some parts were warmer by as much as 15 degrees. That is a big deal. That means something is adding heat where models said there should not be any extra. Scientists started tossing around ideas. Maybe it is volcanoes, heat rising from inside the planet. Maybe it is something on the ground that holds warmth longer, like sand that stays warm after the sun goes down. Then a third idea popped up. These warmer spots could be big pools of liquid. Water holds heat really well. If that is what is happening, then this planet might be more than a rock with air. It might have large bodies of water, and water is the one thing every living system we know of needs. These pools, if real, would be holding on to heat and letting it go slowly. That could change everything we thought about this planet's surface. Then another layer of data came in. The scientists turned to the planet's electromagnetic readings. That part of the data is hard to work with. It is messy. It is full of interference from the star. But the quantum machine cut through the mess, and out came regular, repeating patterns. Not noise, not random bursts, but clear, repeating signals. It is hard to say exactly what these signals mean. They match the timing of the planet's orbit. They shift with the same pace as the gas levels and the heat cycles. It all seems tied together. That makes them worth watching. Each piece of this story came from the same source, a quantum system trained to clean up noise and pull out patterns. These machines are not guessing. They are reading massive amounts of information and lining it up. The same data that looked like junk last year now shows cycles, flows, and spots that hold heat in strange ways. The methane levels rise and fall. That is the first red flag. Then the carbon dioxide swings back and forth every 11 days. That is the second. Heat patterns sit along the edge of the planet, where the light fades into dark. Some spots are warmer by up to 15 degrees. That is the third. Then the planet's signal in the electromagnetic range starts pulsing. That is the fourth. Each one of these on its own is interesting. Together they tell a different story. The surface is not flat or uniform. It has spots where things heat up and stay warm. That does not match any of the old predictions. Old models said it would be cold on one side, hot on the other, and dead in the middle. That is not what the data shows anymore. Instead, the data shows movement. The air flows, the gases shift, the heat builds up in places and spreads out. Even the surface materials might be playing a role. Some might soak up sunlight better. Others might trap heat. The new models being built now will have to start from scratch. And this all came from a machine that looks at numbers differently. Regular systems saw a mess. This one saw patterns. It took in data from different kinds of signals, heat, gas, light, energy, and found places where they lined up. Once they all came together, the picture changed. Yet just when scientists thought they had Proxima B figured out, another surprise surfaced. Magnetic clues from the dark side. People thought this little planet near a red star didn't stand a chance. One side always faces the star and gets roasted, while the other side stays in darkness and freezes. That strange spin made scientists think it couldn't keep a magnetic field. Without that shield, radiation from the star would strip away its air. No air means no water. No water means no life. But things changed. Smart machines found tiny signs in how light moved through the planet's air, signs that suggest a magnetic shield. If it's real, it might help the planet hang on to its atmosphere and protect it from its angry star. That's a big deal because planets near these types of stars get blasted with flares. Without protection, any air or water would disappear. But with a strong enough field, the planet might stay stable enough for water and maybe even life. Some experts are excited. Others say the planet still gets hit with radiation hundreds of times stronger than what Earth gets. The shield would have to be incredibly powerful. But life on Earth shows up in wild places. Frozen ice, deep ocean vents. So maybe this planet has a shot. Earlier findings showed that heat and air don't just stay still on this world. They move around. That might mean there's a middle zone between hot and cold where the temperature stays warm enough for water. If the shield has been around long enough, life might have had time to start. These findings come from new tech that handles huge amounts of data all at once. It checks light, heat, time, and more together. Old tools looked at one thing at a time and missed a lot. This system finds patterns that others couldn't see. It saw the signs of heat moving around and air cycling. The telescope used can spot very faint light and small temperature shifts from far away. But space is messy. There's noise from stars, dust, and background light. Cleaning that up is tough. These new machines move fast, sorting through it all and picking out what matters. The planet was first found nearly 10 years ago, but early telescopes could only tell us basics like size and orbit. One tried to check the air but wasn't strong enough to see through the glare. That's changed now. Instead of just spotting one gas or heat spike, the new system builds a moving picture of everything. It tracks how one thing changes when another does. That's how it spotted the signs of a shield and the movement of air and heat. Before, researchers looked for gases like methane by watching for dips in light. Now the machine checks how those dips change over time and what other shifts happen with them. That's how it found signs of possible seasons and heat patterns. There are now signs that parts of the planet stay warm, that the air moves, and that a magnetic field might be keeping everything in place. These clues don't prove life exists, but they make the planet way more interesting. The team behind the telescope wants more time to study it. They've already booked hundreds of hours to collect more data. New machines, even sharper and faster, are on the way and should be ready by next year. Those will help look not just at this planet, but at others that were once ignored. This newer tech plays by different rules. It checks thousands of possible answers at once instead of going one by one. That's how it finds stuff older tools missed. It also watches how gases in the air block certain parts of light. That shows what the air is made of and how it changes over time, like weather. One older telescope tried this but couldn't block out the star's glare. The new one can. What it found was surprising. It saw warm zones between the hot and cold sides. It saw that gases shift in cycles, like seasons. The shield could be the thing holding it all together. If the air sticks around, moves, and keeps some spots warm, this planet might not be the dead world people thought it was. Is this the first sign of life, or just a planet playing tricks on us? Smash that like button, drop your thoughts in the comments, and don't forget to subscribe.